Welcome to the cloudonaut podcasts. We are your hosts, Andreas and
Michael Wittig.
We discuss
In
all
this
things
podcast,
AWS and share our insights into our day-to-day work. This is episode 67, which we are recording on January the 18th in 2023. In case you're watching this live on YouTube, feel free to ask questions in the chat. And here's a message from our partner. Are you looking for a job? AWS expertise is in high demand. Our partner Demicon is looking for a cloud operations lead working remotely from Germany or the EU. Lead a growing team of cloud architects and DevOps engineers, manage service delivery, and hire new team members. Demicon is one of the largest technical consulting teams and a leading Atlassian full service provider in Germany. Join Demicon building their new business unit with a focus on cloud technologies. You will find more details in the show notes or video descriptions, and if that fits for you, then you should apply today. Okay, Michael, so we decided to redo the format of the podcast a little bit. So within the next weeks, our approach is that we share a little bit of insights into our day-to-day work, discuss things that we found out about AWS or maybe that surprised us, stuff like that. So that is the focus of our show. We are no longer focusing especially on the news. So we are just focusing on stuff that came along when building on AWS. That's what we do every day. So I'd like to start with two things that we are currently working on, or I have been currently working on in the past week. So there's good news because the third edition of our book, AWS in Action, is very close to getting printed. So I've been reviewing what the publisher Manning is calling first pages. So basically, they do the layout of the book, and then they send you PDFs with the pages, and you have to review them and mark things that have not been translated from our manuscript into the layout correctly. So that's what I've been doing. This is one of the last steps in the whole process. So I'm really excited about that. And besides that, we've been doing a beta test for the AWS debug games recently, and I've been collecting feedback from various participants or players actually, and I have something other to announce, which is the AWS debug games are now in public beta, which means everyone who wants to try out is able to do so. It's games.cloudonaut.io. And there you'll find two games to prove your AWS debugging skills. And of course, you learn a lot while doing so as well. So we have some guides and stuff that help you to go through those games. And basically you debug issues in an AWS infrastructure. So what have you been up to, Michael?
I want to share one feedback that we receive from players, and I think most of them report or kind of send us feedback, and they tell us that they learned something new. So for example, when you debug the VPC issue, then chances that you will use a new tool that you never used before are very high. So this is really something interesting for you to check out. So if you and I think the games are not, they maybe take 10 minutes to play, right? It's not a lot of time that you need to invest, so you can try them out, and there is very likely something for you to learn, even if you are using AWS for a long time, as well as for beginners. So that's just one thing I want to add, Andreas, here. Yeah. So what I did in the last days is we launched a new feature for Marbot, which is our AWS monitoring chatbot. And I added a feature that we call Monitoring Assistant. And basically what it does is you can connect now your AWS account with Marbot, and then Marbot creates CloudWatch alarms, EventBridge rules, and all kinds of things that are necessary to monitor your workload automatically. And this was added at the very end of the last year for Slack workspaces. And what I did in the last days is I basically enabled these features for Microsoft Teams as well. So now you can, in Microsoft Teams, connect your AWS account as well, and then Marbot basically in the background runs Terraform for you. And that's kind of what happens under the hood. And one thing that I learned here, Andreas, and that is what I want to share with the audience is we use the new EventBridge Scheduler in the background to trigger our Terraform apply runs every 6 hours at the moment. And what happened is that when someone disables the feature or disables a region, basically an AWS region, we delete the schedule as well. And what I did is I was assuming that when I delete the schedule, I will not receive further invocations for the schedule. Turns out that's not the case. So in some situations, it is possible that the schedule is deleted, but you will still receive an invocation a couple of seconds after that. And this was confusing because the code was not expecting that, so I was kind of relying on it. But it's not the case. It's not very clearly documented, but it's not documented at all, so neither behavior is documented. So from observation, I learned that it's possible that an invocation happens after the fact that you deleted the schedule and you get the call, the response from the API back. So what we now do in our code, we basically check before we run Terraform if it was destroyed before. Because what happened is that we run Terraform destroy, and then the schedule fired another Terraform apply, and then we rebuilt all the infrastructure and we had to delete it again after that. So and now that's not happening anymore because we have a check for that in our code now. Mm-hmm. So we make sure once it is in the disabling state, it cannot be applied anymore. Yeah, so that's something that I want to share, Andreas. I don't know if you are surprised by that or not, but
at least I didn't expect it. So it makes kind of sense because it's probably most likely a highly distributed system. So it makes sense that it's not, or that's eventually consistent. So yeah, but I wouldn't have expected it probably as well. So very interesting learning about the EventBridge Scheduler. Okay, let me proceed. So I learned new things about basically a tool that I've been using for years recently. So that's sometimes that happens, and I like that a lot when when you learn something new about something that you have been doing for quite some time. And so I'm using Packer by HashiCorp to build AMIs, or we both use it. Probably many people out there use it as well because it's a very easy to use tool to build your AMIs to deliver your applications or do golden AMI, stuff like that. And I learned two things. So in scenarios where you use multi AWS accounts and you want to encrypt the AMI, what you need is you need to use a specific KMS key, a customer managed KMS key, to be able to share this AMI with other accounts, for example, in the organization. Because the default key, which is the other option that you can use to encrypt your AMIs, is only valid within one account. So you cannot pass an AMI to another account because that account cannot use the default EBS key by KMS. So that is why I, from time to time, have to use a customer managed KMS key when building AMIs with Packer. And while watching the deployment pipelines that is building an AMI with Packer, I was noticing that it takes quite some time to basically finish the AMI at the end of the whole process. So Packer starts the EC2 instance, then it creates the AMI, and after that, basically, Packer was starting to copy the AMI and encrypting the AMI. And this took several minutes, 5 to 10 minutes. So this is really quite significant. And I was wondering whether there is a way to speed things up a little bit. And the good news is there is a way to do so. And the thing is, when you use Packer, and then there is an option basically that says encrypt the AMI, and you can also provide your KMS key. But by doing that, at the end of the whole process, basically, you are copying the AMI and then encrypting it. What you can do instead of that is when launching the EC2 instance with Packer from the base AMI that you are starting from, you can at this point say, I want to launch an instance based on this AMI, but with an encrypted EBS volume. This is possible in Packer by using what is called a launch block device mapping. So this is just a configuration parameter. And by doing so, basically the instance that Packer starts launches with an encrypted volume. And when you then create the AMI, it is automatically encrypted with the same key as well. So this frees you from copying the image at the end of the Packer process for encrypting it. And this speeds up things significantly. The main advantage is when you not have to copy the AMI to multiple regions, because if you have to do so, you still have to copy AMI job at the end of Packer. But if you're only building for one region, then this really speeds up your Packer process significantly. So summarized, when you build encrypted AMI, use the launch block device mappings and set encryption and KMS key there, instead of using the more general encryption, basically, of the whole Packer process, which does a copy at the end of it. And so that was one thing I learned about Packer. It speeds up things. And then I looked into something different. And because the problem I had is, so we typically try to avoid SSH connections those days. So whenever we launch an instance, typically we do not even open the TCP/22 port for SSH connections anymore, because we use the systems manager session manager for those things. Because it's very, I think, a very good thing to do, because the authentication is then handled by identity and access management of AWS. And also you don't have to open all those ports and stuff. So I think it really makes sense. And in this specific scenario, I didn't have a network where I could reach the SSH port at all. So I was limited. And I was looking for a way to build a Packer image without having an active SSH connection to the machine that Packer starts. And I thought, oh, maybe Packer supports the session manager. And I was not expecting that this works out of the box, but the good news is that Packer supports that out of the box. So it's really, really easy to use. So all you have to do is there's a parameter called SSH interface, and there you can just specify session manager instead of SSH. And then the other thing you need is you need to define an IAM policy for the EC2 instance that is required for the SSM agent to contact the SSM API. So you use a temporary IAM instance profile policy document for that, where you just allow SSM messages, EC2 messages, and so on. So the thing that is needed for the session manager. And after that, Packer spins up an EC2 machine and then uses the session manager to connect to the machine, which is really cool and frees you from open the TCP port 22.
Like one question, Andreas.
Mm-hmm.
Like is like the example in the AWS in Action book. I remember that you created that new chapter. So is it using this way as well, or is it using the old way?
I think unfortunately I did that before I learned about this feature.
Okay, I see.
So I might. So it's maybe a little too late to change this, but yeah, it would work there as well.
But I mean, the downside is that it requires an installed AWS CLI with the session manager plugin, right? Yes. I think that's how it is called. Yes. So I mean, it's a little bit harder to get it started. Yeah. Because most people will have an SSH client. Yeah. But probably not this plugin installed.
Yeah. Yeah, but it was very helpful, and I think for the use cases that I have, I will probably use it as a default in the future. Yeah, so this is how you.
I also.
Sorry,
I also changed this in Bucket AV, so the way we create the AMI there is also now using session manager.
Mm-hmm. Yeah, cool. Yeah, so I think those two things speed up Packer when using KMS encryption and use Session Manager instead of SSH. This is really two cool features of Packer that I didn't know before. I wanted to share here. I will put links to all of that in the show notes. So if you want to apply that to your own setup, you'll find links for that in the show notes. Michael, I have one more thing for today. So
Yes.
actually, when I said at the beginning that I was reviewing the first pages of our book, the third edition of our book, and I was reading through the Lambda chapter. So we have a chapter on Lambda in our book. And at the end of the chapter, we have some examples of what you can do with Lambda as well. And one is talking about the possibility to configure VPC for a Lambda function. So you can enable VPC connectivity for your Lambda function, specify the subnets and stuff like that. And I looked at the figure that we had there. It was just saying, okay, the Lambda function now has access to resources in the same VPC, like an RDS instance or another EC2 instance or stuff like that. And also it allows connectivity to the internet. So any third-party APIs that you want to use or stuff like that. And I was stumbling upon that because we, in the figure, we just had an internet gateway in there. So I was wondering about that. Does that really work? Because I had something in my mind that something is tricky here. And then I've tried to find out in the documentation, and so it was not clear to me, and I just was assuming that this will work because of the things that I've been reading in documentation. But then a few weeks later, I deployed the Lambda function in a VPC in a public subnet, and it was not able to reach APIs over the internet. So I was looking into the details, and then I remembered something that I learned probably a few years ago already, that when you configure VPC for a Lambda function, it creates an elastic network interface for that function. But no matter which subnets you choose, the elastic network interface of the Lambda functions only gets a private IP associated. There's no public IP address associated with the network interface. So that means because the public internet IP address is required for all resources that want to use the internet gateway for outbound communication, this is not possible. So basically what you need, no matter if you deploy it into a public or a private subnet, you need a NAT gateway to be able to contact third-party APIs over the internet. So that was an important relearning of a fact that I'm 100% sure that I've been running into that before, but I just forgot about it. And this is just about the small details that you need to be aware of.
Andreas, that's a very good game number 3, right? I mean, we could just deploy a Lambda function in the public subnet without a NAT gateway, and then the
right.
player has to figure out why it's not working.
Oh, Michael, that's very good. Yeah, I have to do that. Yeah, and I hope that others can use my example to maybe learn about it for the first time or relearn it so that you're not running into that the next time you use VPC for Lambda functions.
Yeah.
Okay, Michael.
All right.
That's it, I would say. We will be back next week. In the meantime, subscribe to our newsletter, podcast, or YouTube channel to make sure you're not missing the upcoming shows. Also, we want to thank our supporters who make this show possible. Please consider supporting our work with a recurring or one-time donation as well. You find details and links in the show notes. Thanks a lot for your attention. Bye.
Bye.